Welcome, my viewers and subscribers. Welcome back to another video. This is JK Engineering and Architecture, where I covered engineering as well as architecture related topics. Now, as a follow-up to my last video, where I went over the topic of engineering project management as it relates to how to schedule your construction project. Now, this exercise is a good exercise in my opinion if you want to know how long your project will last. And as it's been constantly said, that time is money. Now, most large scale construction or medium to large scale construction adopt this measure to track how long the project lasts as well as how the project is proceeding in terms of the budget. So you can use this critical path method to track the money being spent at a particular time in your project. Now, as a follow-up to my last video, I went over how to calculate the duration of the construction project as well as how to calculate the critical path. And as I've mentioned to you before, that the activities on the critical path must be done in the allotted time or the allotted duration if you want to complete your project on schedule. So I am just going to go over a few items that I think can provide more clarity as it relates to this topic. In my last video, and let me say this before I continue, in the event that you're watching this video for the first time and you have not seen my previous video, I will implore you to go back and watch my subsequent video to this video so that you can follow what I'm saying in this particular video. Alright? So in my last video, I went over to calculate the critical path. Now, as I've said before, there are two ways that you can calculate the critical path. The critical path is that part that has zero floats, meaning the activities on that part has to be completed within the allotted duration. Also, you can calculate the critical path, and your critical path is usually the part with the longest activities or the longest duration. So I'm going to go over that very shortly or momentarily. Also, I've shown you how to calculate the float, and as I've said to you before, the float is the late start minus the early start, or the late finish minus the early finish. So let me demonstrate to you now how to calculate the critical path using the zero float method and the longest path method. Now, as in the case of the last video, and as I said to you before, if you have not seen my last video as it relates to this topic, you need to visit that video so that you can follow what I'm saying. So in my last video, we went and we plotted the diagram, the critical path diagram, and we have here activity A with 5 days duration, activity B with 8 days duration, activity C with 6 days duration, activity D with 9 days duration, activity E with 8 days duration, activity F with 6 days duration, and activity G with 1 day duration. And I've also indicated the purpose of all these activity A, B, C, D through to G. I have already indicated what are the purpose of these activities from my last video. Now I'm going to show you now how to calculate the critical part. And the critical part of this project, coming from our last video again, is from A to B, from B to D, and from D to G. So therefore, the critical part for this project is activity A. Sorry, let me use a better pen. Is activity A, activity B, activity D, and activity G. So activity A, activity B, activity D, and activity G are all on the critical part. So these activity must be completed. In other words, activity A must be completed in 5 days. Activity B must be completed in 8 days. And activity D must be completed in 9 days. And activity G must be completed in 1 day for this project to finish within 23 days, because the duration of this project is going to be 23 days. In the event that there are any delay in the project due to unforeseen circumstances, in the event that you have consistent rain over a period of time, you must go back and adjust your schedule for the time that is lost. And I'm going to do a video where I demonstrate that as well. So, how we know that activity A, activity B, and activity D, and activity G is on the critical part? These activities they all have 0 floats. That means there's no time to waste on this activity. There are no days to waste. It has to be completed in the allotted time. So, how we know? So as we said, we are going to calculate the float, and to calculate the float is your late start minus your early start, or your late finish minus your early finish. So in this case, 0 from 0 is 0, 5 from 5 is 0. So the float here is 0 days. In the event of activity B, we have 5 from 5 is 0, 13 from 13 is 0, so we have 0 days float on activity B. Activity D, we have 13 from 13 is 0, and we have 22 from 22, which is 0, so we have 0 days float. 0 days float. So activity G, we have 22 from 22 is 0, and 23 from 23 is also 0, so we have 0 float. So therefore, you can evidently see that on the part A, B, D to G, there are 0 float. So obviously, this part is on the critical part. These activities are on the critical part. Now, let me show you the float on the remaining activities. Activity C, activity E, and activity F. So, if you should subtract your late start from your early start, which is 8 minus 5, that is 3. And if you should subtract 11 from 14, that is also 3. So therefore, activity C has 3 days float. So that means when you finish activity C, you can wait 3 days after to start activity F, right? So let us look at activity E now. Activity E, we have 14 minus 13, that is 1, okay? And then we have 22 minus 21, that is also 1. So activity E has a float day of only 1 day. So 1 day float. right? Activity F, if you subtract 11 from 16, you're going to get 5. And if you subtract 17 from 22, you're going to get 5. So that means activity F has 5 days of float. So that means activity F can linger for 5 days until you start activity G, right? So that is one way how you can calculate the float and how you can calculate the critical path. Now the second way how you can calculate the critical path, your critical path is usually the longest path. So all we have to do is just add up the duration on each respective part and see the largest of that part, and then we come up with the critical path. So we're going to test now if activity A, B, D, and G is on the critical path, and therefore activity A, B, D, and G must be our longest part for this to maintain as the critical path. So we are going to test that, right? So let's work with me now. So we have 5 plus 8, that is 13. 13 plus 9, that is 22. And then 22 plus 1, that is 23. And you notice we come back to our 23, the duration of this project. So part A, B, D, G as 23 days, right? We're going to look at part A, C, E, and G. So part A of 5 days plus 6 days, that is 11 days, and 8 days, that's 19 days, and 1 plus 19 is 20. So part A, C, E. So part A, C, E, A, C, E, and G as a duration of 20 days. Okay? So we're going to check part A, C, F, and G and see what's the duration on that. So part A is 5 plus 6, 11. 11 plus 6 is 17. 17 plus 1 is 18. So we have part A, C, F, G, which is 18 days. So let's see if we have any more part. So we have checked part A, B, D, G, part A, B, E, G. So we have one more part. We can check part A, C, E, and G. Now we checked that part already. So let's see if there, yes, there's one more part. So we have part A, B, E, and G. So that's part A. So part A is 5. 5 plus 8 is 13. 13 plus 8 is 21. And 21 plus 1 is 22. So we have part A, B, E, and G, which is 21 days. So we can see now that part A, B, D, G as the longest path, which is 23 days. So our answer was correct. A, B, D, and G is on the critical path, and it is the longest path. Right? And if you notice, the critical path comes back to the duration of the project. So that is an exercise that I wanted was to bring to you. In my next video, I'm going to do another example so that you can get more familiar with this exercise. As I've said to you before, this is a good exercise. A lot of project management company does this for huge construction or any project you have and you want to finish that project on time and within budget. So if you're running a small construction company or a small project, you can work out this. You just put the different activities to the work on your site, give it a reasonable amount of days that you think you can complete that activity, and then you can work out the total time to complete your project. And you can say to your clients or whosoever you're working for that this project is going to cost you X amount of dollars, and we're going to take X amount of time to finish this project. So that is it for this video. And as I said to you before, I'm going to be doing more example of these so that you can get more familiar. For those of you who want to learn, it is here for you to see. So for my regular viewers and subscribers, you know what to do already. And if you're new to this channel, do remember to subscribe, hit the like button, and leave a comment. Enough respect. Take it easy.